Good morning, good morning. Godot gave me a home and trash icon on my desktop now. That's pretty cool. Wasn't there before. Ah, I like how the Godot tutorials, they just have a math tutorial. Just like, this is everything you ever need to know about math in this tutorial. Okay, so let's try to wrap this up. Let's change our uh, title here. So really, we hopefully could get the Makarov shooting. Cool. So that's probably our next goal. And then I'm spending quite a lot of time on you know, the clockwork of the pistols, which is very fun. And so there's nothing wrong with that. If this game is going to be fun to play, we also need like some enemies, some maps, whatever. So I gotta spread the love around to the rest of the game as well. So let's finish this up, even if it's not perfect. Take another chunk of time to work on the rest of the game because that's going to be fun too. I've got a bunch of cool stuff, hopefully, to add in the way of enemies and puzzles and exploring and such. So let's get to it. So if we want to finish up the Makarov and we just want it to shoot. We finished up last night with some pretty good headway. We fixed the margins on this hitbox, so because these are all such small objects, they're millimeters and centimeters scale, across. Um, Need to brush my hair a little bit, don't I? Oh well. It's first thing in the morning. 10 a.m., that counts. Uh, but we've got that working much better. But what we really got working is the ejecting. So that's still pretty cool. And it works better or worse. And we've got the magazine hold open working. So as we're on that last round, magazine's gonna hold open just like that, like it should. Now, there's still a couple things we need to fix here. So what we left off on last night is the rotation of the cartridge as it comes out of the chamber is a little off. So it's rotating around the global y-axis, which sometimes looks right and sometimes doesn't look right. We want it to rotate around the its local y-axis, which I'm pretty sure we can figure out how to do. Similar to how the character moves and rotates, right? So we can copy some code from that, or we can just read the fine manual. So the other problem, and this is probably what I'll do first, is if I release the slide right now, it's not going to strip around. Did it? Oh, it did. There we go. If I go quickly enough, it doesn't. If I go quickly enough, it doesn't. See, we don't have a cartridge right now in the chamber, even though we should. See that little bit of a delay? Hmm. See, we just didn't pick up a cartridge again. We're not short shucking it because, see, we went all the way back, right? Whereas if we slide it forward, we do pick it up. So I think we might just be missing some code in one easy spot, which would be great. The sun is shining, by the way. I don't know if you can see out my basement window here, but got nice bright sunlight outside, which means the whole desk is running off our solar panels, which is pretty cool. That's neat. Uh, Reasonably straight screen. That's good. That's good right there. So, uh, I think the line of code that we're missing is maybe in here. Okay. Got this onside motion. So this is listening to an event that's being broadcast by the slide, and you can see it right here. We definitely emit that signal when we're dragging it, but do we emit the signal down here? I don't think we do. See that? Well, we do. We do emit the signal down here. Hmm. So maybe my threshold is just a little too steep and it flies past before it has time to... Hmm. Or, look at the logic over here. Because does this have the direction correct? Because the arguments to this are percent open and moving in open direction. Although, what am I saying? Percent open and moving in the open direction. Right? So that's not it. It's not as easy as that. So I wonder if this threshold is too large. Right. I also wonder, so here's a question. If, and this isn't a perfect analogy for a Makarov because it's a different pistol, right? But we can use it as just kind of a reasonable example. So if we chamber around, right? So see that round going in there? And then we go back to the point at which it would eject. Right, so here it's coming out. And then right there is where it ejects. There you go, right? Now, if I just come forward from here, will it strip another round? No. We have an empty chamber right now, even though we have a loaded magazine. Yeah. The round came out. There was a cartridge ready to be picked up from the magazine, but nothing got picked up. It's empty. So those are two different positions. Now, do I care? Maybe not. Maybe we're going too deep into the minutia here. Uh, but technically, uh, that is how it would actually work. But maybe uh, we've got 90% set as the eject point. Right. What if we kind of move this up a little bit? We say 85%, we eject, and then 90%. Yeah, yeah, let's try that. Let's just see if I was just. We might have to make sure that that always triggers when you're actually shooting the gun semi-automatically, right? Uh, which that should work. But let's see. Let's see. So, all right. So, see, we didn't strip around. You can hear it, which is cool because of the sound effects, but we didn't strip around just there. And if you look in the chamber, see, the chamber's empty. Try it again. See, again, we didn't get a cartridge. Now, if we do it more slowly, it works. And even if we go like here, you see that delay where that cartridge just moves ever so slightly. There, we got it. Why is there that delay? That seems really peculiar. So I don't think I'm quite understanding. Take it gets. I don't think I'm quite properly understanding what's actually going on in my code here. So let's try to add some log statements and kind of tease this out a little bit more. So let's get our log screen ready to go. And drop top. I can always fiddle with that more later. That's going to be plenty good. Cool. All right. And Here we go. Let's go print. Keep this really simple. Hey, Kitty. Kitty. Good to see you. Good to see you. Now. Oh, isn't Kitty OnlyFans careful? He's very cute. I should probably close that window that I had open for you guys to watch out of because it's still pretty chilly, isn't it? Hey, Kitty Cat. Uh, yeah, what's the weather right now? It's getting warmer. Okay with that. Still there. Having a little bit of a confrontation. What were we doing? It's opening. Okay, let me go close that window. Otherwise, I don't want to overwork the furnace, you know? Real trouble is the cat's gonna want my oats, but it's all right. So, uh, slide motion. It's opening position. So now let's just see if we can figure it out just from that. Before we go too much further. Now I've got my... There we go. Alright. I could... Well, I could maybe clear the log, but that's alright. Magazine latched. That's cool that we still have those print statements in there. So that's all accurate yet. So, if we just do a little open close. Oh, now that's interesting. You see that? So it opens to 50%, but then we only got one close message when it was at position fully closed. See? Again, that's the problem. So let's look at how that logic happens. If we look at this slide, inside the process function here, right? They're kind of running under the table, so you might not be seeing them, but the cats are flying. Which is good. I'm glad they're keeping each other busy. So you see, this block of code here is where it actually does the close. And so that's really weird, because I think that's going to be having more accurate information in it than is being received by the signal. Okay. So we're watching the log at the top here. We're going to open it halfway. Does it really close so quickly that it just doesn't even have a frame of being open? I wonder if we, here's a thought. I wonder if we move this signal before we actually move it, right? We'd even emit a signal twice if we need it, but oh, hey cat. uh, right. I wonder if it just slides home that quickly. Hey, kitty, you want my food, don't you? Yeah, you gonna steal it? No, no, no. That's my breakfast. Sorry, girl. Try this. There you go. It goes quickly enough that it only is one frame. Yeah. Now, did we actually pick up a cartridge there? Yes, we did. Okay. That works. That works. Now, is that too fast of a closing speed? What would it look like if we slowed down the closing speed? Even by like half or a factor of 10, right? Ha ha ha. Yeah, okay, that's way too slow. Um, how about just by half then? It still feels pretty good. You know, compare that to... It's hard to hold it. Nah, it's fast in real life, so I mean... I suppose it is kind of a one frame type of thing. That's too slow, I agree. That's too slow. I think it should snap. So yeah, I think that's the solution, is we just emit the signal before we move it. Maybe even before and after we move it. Yeah. Hmm. I think that does it though. I think that fixes it. It's pretty cool. Yeah, that doesn't look bad either. No. If anything, it would be kind of cool to get the, if you move the slide slowly, it dribbles out slowly working. Um, and I'm thinking about it, so let's just do it. So, let's turn off gravity again briefly. Gravity is off. Now, let's make this 0 for a second. And then let's see what kind of the minimum dribble speed could be, right? So if we do 0.5, if we do half speed. Right? That's slower. And if we turn gravity back on then, right. Uh, that looks about right. Okay, and how can we make this math simpler? This is a little goofy. So if we do this, if this is going to be another 1, and we can do this, 1.0 times y times slide speed over 100. Yeah. I can type. Okay. That should work. So it basically, it should slow down or speed up. Right, but this is a percent travel number. So in most cases, this is actually going to be a pretty small number. So maybe that's my problem. Right, because right now I don't think that's actually having much of a difference. Right, so like let's say you move. Let's just try this. Let's just kind of play with it. I think experimentally is going to be the easier way to do this one. Ah, that's the double feed bug. I'll have to figure that out at some point. All right. So here's the thinking. We go really fast. Oops, I'm grabbing the hammer. You go quickly. If I go slower, yeah, and that did work. Yeah, and honestly, that seems reasonable. The only thing we could do there too is we could adjust the spin speed. Um, if we go here, we can add an extra parameter. Now, this might be comical. Yeah, that didn't spin it much at all. See, that spun it more. That worked. That's pretty cool, actually. So that seems reasonable. Get in there, you. Right. Woo. Yeah, now it's a little too accentuated. Because it should spin a little bit no matter what. So what if we say... Maybe? What would that look like? Maybe that's too much. Maybe we just have a ludicrously high number right now. It's the first time I did that on accident with the new hitbox, but that was just my fault. I brought it too close. Cats are playing. Alright. Okay, that didn't have much spin. That's good. Now, it wasn't spinning the right way, so we should... That seems a little low. And it's spinning the wrong way, I think. So... What if we increase that a little bit and this a little bit? And then I feel like the minimum kick-out speed could be a little lower. So 0.5, what if we make this 0.2? We just don't want gravity to overtake it quite so much that it can, like, bump into the gun itself. Now, we could kind of help that out by moving the launch point, or the release point a little further to the right. So we've got options there. Okay. Yeah, it collides with something. It's interesting. Yeah, I'm not fully sure what happens when it does that. It doesn't mind clipping through the gun. It doesn't mind clipping through the gun. But maybe it hits the other cartridges. I wonder if we go here. We go to... I wonder if it's colliding with the other cartridges. So if we look at its collision mask, do this. Well, but we're probably not going to be able to insert it into the magazine then. Oh, we can. Okay. No, that doesn't fix the issue. Hmm. Interesting. I don't know what is going on then. But it doesn't happen if we punch it out with enough authority, right? I don't know. I don't know. We could try. We could try. Yeah, we could also change it to a rigid body. I wonder what that would do. I wonder what that would do. If we look at the cartridge, change type to rigid body, because uh simulation. As opposed to a kinematic body, which is what we have right now. Sure. Okay, so we've made it a rigid body. Ah, but then we can't move and slide it. Now, maybe there's an equivalent because we want to just give it a velocity, right? Maybe there's a better option then. Oh, this cat's gonna eat my food. I don't uh finish it up. Sorry, Kitty. I'll eat that so I don't keep torturing you with it. Oh, cat. Hey, girl. Sorry, babe. Might have to go upstairs. started playing. They've been distracted successfully. That's good. All right. Set linear velocity. Let's try this. All right, let's go ahead and comment this whole thing out. 'Cause if this is true, there's not going to be a physics process method here. Hey, good morning or good evening, Captain Verbal. How are you? Toggle comments. I'm actually trying this as a rigid body. I'm curious to see what that brings us. It's been Saturday over there for you. Oh, I can't click on it. That's why. Nice. Sure. I'm trying it, although it causes me to not be able to click and drag them, so I guess never mind. Now, what I could do is I could have two different objects. One for when it's click and draggable, and one for when it's free falling. But yeah, as it stands like this, that's not going to do it. So eventually, I think I probably will do that because that probably has a lot of advantages. But we have it working decently. Probably. Yeah, I'm not sure what kinematic mode is. What does that do? Yeah, I believe it. I believe it. Um, let's see. So I toned these numbers down a little bit. Let's bring them back up slightly. And then I think we've got a working we've got a working system. That's just going to be fine for what it is. Oh, and then I actually have to change it again. Let's go back to kinematic for a minute. Now we can click and drag them again. So that's why they have to be kinematic right now, so we can do this. But we'd have to have like a hybrid approach, like flip-flop it. Good Saturday, good day for you there. Doing anything fun? Playing any new games? I've been doing some of the Cycle Frontier, which is kind of space Tarkov. It's a good plan. My two viewers are here at the same time. Awesome. Yo, hey, good morning, Spectre. Kinematic mode on rigid body will just not let physics interact with it. Ah, success, success. That might work if it lets me kind of like treat it as a kinematic body and a rigid body. I think this is gonna be good enough for now. Because if I open this slowly, it still pops out of there pretty quickly, but you can tell it bloops out of there slower if I open it slower. So that's good enough for me. And it also spins slower if you bloop it out slower. So that's probably gonna be good. That's probably gonna be good. No, no worries. It's good to know that's even an option. So, uh, but let's make this. Yeah, see that looks right. It looks right-ish. And if I go a faster opening, then it's eh. We could speed it up a little bit when you open it quickly, so we could have this multiplier be a little bigger, but we're kind of splitting hairs at this point, so let's go do the next thing. Let's do this. What if this is like 1.6 or something? Thank you, thank you. Do some of that. All right, last. Oh, you didn't see that. There's no bug with the magazines. All right. I wonder what this will do. I wonder what this will do. I wonder if we watch this round over here that's kind of smashed into this magazine. If oh no, we don't need the debug menu open anymore. Uh yeah, this one this one moves up. Um, but since we increased to that multiplier, yeah, that pops up with a little bit more authority, and then it still goes slowly. Yeah, that's good enough. Okay, so what's next? We want to actually make it shoot, and technically, there's well, let's get rid of these print statements. We figured out that bug. Basically, the slide was just closing too quickly, and so it was skipping over the round, and it wasn't picking something up. Nice. Gave up on subdivision? Yeah, I don't subdivide. I don't. I use bevels. Bevels are nice. Um, yeah, with the exception of the uh, the grip, the Makarov grip is subdivided, and that was my only foray into subdivision modeling. But that took me a while. That was a little bit of an effort, but I think it turned out all right. Bevels are good. I get a little scared of booleans because sometimes, especially if it's like a complex shape with like an inside geometry, like booleans don't always work. You gotta like do that checkbox for like intersects itself or whatever, and then it'll work. But yeah, this had a little bit of subdivision to it. Does it still have it? No, I applied it, but uh, that's the only subdivided bit on this guy. And then everything else is, whatever. Take take an edge and bevel that bad boy, sort of thing. And then, you know, make nice looking corners like that. little extra, little extra like smoothness to it or whatever. I don't know. I just know enough to be dangerous as I point a gun at the camera. That's illegal, right? On live TV. Uh, Boolean causes probably around 80% of the problems most people have. Yeah, totally. Yeah, including even more so subdivision, for sure, for sure. Thank you. Well, it's really not. It's really a very messy mesh. So thanks for saying. There's definitely a couple spots where like there's double vertices, and I've tried merging by distance, and it doesn't get all of them, and it's close enough, right? It's close enough. Uh, okay. So there's one thing here that we haven't programmed yet, that we probably should do before we make it shoot, and that is the hammer. So in in real life, for realsies, the here, let's be very careful about this. Okay, chamber's empty. I'm gonna drop the hammer. There we go. Okay. Uh, if the hammer is uh, uncocked, then if we run the slide, right, it automatically cocks it for us, right? In the game, we don't have that yet. We don't have that yet. So we basically have copied the hammer trigger logic from the revolver right now. So we can manually cock it, and that works. But if we run the slide right now, nothing happens, right? And this is gonna get messy, but we can program this. Um, Now we don't need to technically to make it shoot. We could still just like make it shoot, and then program that later. But it would let's do it because we're thinking about it. So when we open the slide, and it's only the first little bit of it, it should actually move the hammer. Um, and it's kind of complicated because the hammer. Can I show both mags and fill them a bit again? Yeah, right. There's a bug there, and it has to do with the cartridge gets loaded into both magazines simultaneously, and I don't know quite how to fix that, but I'll fix that down the road. I'll kick that can a little bit. Let's see. Um, right here is our. Uh, I agree with you though about modeling uh just something simple to start with when you were talking about making the Glock, because um my first iteration of this game, I think I still have it in here. Right? If I can I open another instance of Godot? Sure I can. I think it's this one. Yeah, there we go. This is kind of cool. Totally. Yeah, we can totally do this. Yeah, all right, here we go. This was my first iteration, right? So that was my that was my first gun model. The uh the audio is very loud on this. Sorry. That was probably deafening. Um but anyhow, what long about way of saying um what game are you making a model for? Thank you. Yeah, I mean it's exactly the same mechanics. A lot of the code is copied and pasted. The idea was just like gray box quality, right? Like see if it even is fun, if it works, if it's a good idea. Let's see. So let's get out of this. That's cool that I can have two open at once. Oh, I guess I already knew that because we had a multiplayer version working, but you can't run two at the same time and have them talk to each other. So you need to have one as a binary, like the server binary, and then the client can be Godot runtime. Just doing some modeling. Nice, totally. Yeah, absolutely. Nothing wrong with that. Model I made was a D&D character that a friend uh like 3D printed. Nice. That's really cool. Um 3D printing looks awesome. I definitely would uh be interested in learning more about that because that looks like cool stuff. And it D&D is a lot of fun. I've not done a ton of it. I did some Pathfinder, right, which is like just a slightly different fork of D&D, right? Um, like in that context, it totally makes sense because if you had like your character and you didn't have to just take a miniature that looked close and then paint them, you could actually like print a custom character like that. That makes absolutely sense. Depending on the printer, can be messy. Interesting. I didn't know that. I would believe that. I think my parents do some of it because they help with their robotics team for the elementary school or whatever. So they'll print parts for the FRC robotics, the gears or scoops or whatever. So let's see. Where was I? Sorry. Um, the hammer. The hammer. So if we look at the hammer code here, it listens for this command, which is a signal coming from the trigger. And when the because it's double action, right? When the when the trigger is pulled, unlike this one's a single action, so I can't really demonstrate that here, right? But uh, as you pull the trigger, the hammer also uh, rolls back. So we could either add another signal here. Interesting. That's a good point. I wonder if that's more of a Europe America thing. Yeah, I could see that. I've heard a lot of stories about the guy who invented D&D. Like, didn't have his driver's license, but he got really, like, well off. He did really well from selling the game, so he like, I don't know, he'd do silly stuff, is from what I hear. But I don't know if those stories are all true. Uh, okay. On trigger double action progress. So we could either use the signals that we already have here and kind of piggyback them, or what would make more sense maybe is add a new signal and have it be a similar, but have it just be clear what's actually happening. I think that's the strat. So let's see at this right here. Let's go to the slide and let's add a similar signal. So let's go. Hmm. Well, actually, I already do have a signal here called slide motion. We could, yeah, no, I don't think that's the way. Because we already have a signal here. We don't want two signals for the same thing. This is really the same thing for a signal. So let's do that. But then the hammer is going to have to listen to that. And so we can set that up in the ready function over here. So we go ready. Well, and we don't even do it in code. We can do it manually here. So if we go hammer, the slide emits the signal. So we can have more than one listener, right? I'm sure we can. We go to the hammer on slide motion, right? I think that's good. Now, here's a thought. Here's a thought. Ideally, the code here kind of reflects the actual physical reality of what's going on, uh, so that our code only operates on the bare minimum, like the code actually moves a lever or something, and then the code for that lever actually, propagates its effects to all the other different clockwork parts that it needs to. Instead of having really complicated spaghetti code, this is kind of like very object-oriented programming, but like for physics, kind of. I don't know. Um, Instead of having a lot of very specific one-off functions that say when this lever moves and that lever moves and this lever moves, this one specific thing happens. Instead of having that, have it be more modular. If this moves, it pushes that, and that's it. And then whatever that pushes, it takes care of propagating that effect down the pipe. So the slide is only gonna push on the hammer, right? The slide's gonna push on the hammer. And then just like when you move the hammer manually, that's in turn gonna move the trigger because it's double action. So moving the hammer actually changes the trigger's position a little bit. But the hammer's gonna take care of that with this existing signal right here called cocking progress. And when that signal is emitted, the trigger moves on its behalf. Okay, I got there eventually. Sorry, I'm slow. Uh, so the hammer, we've got this new on-slide motion. So if the slide is moving in the open direction, and now where can we take as an example from here? This is going to be kind of like a drag rotation, really. It doesn't actually use that event method. I wonder if we can even apply. No, it's not quite like that. Right. So, but we can reuse a lot of this. And if any of it's super common, we can like put it out into a function. We do this. And we can stack these if statements. We don't need to make this one big. There we go. Yeah, yeah. No, I don't. Sorry. I can grab one too. No. Uh, yeah, absolutely. I think I'll go to the store today. Yeah, 100%. There's a there's a little post-it note on the back of the door that shows when I changed it last, and it was probably uh a while ago. Back in December. Yeah. Sorry. every 3 months is what it's supposed to be, right? That's not too far off. I mean, I usually get the cheapest one too, or maybe like one over that, so nothing wrong with that. Yeah, well, I suppose maybe if you had asthma or something, but let's see. Uh, so this is the rotate and clamp, but we're gonna do something slightly different. So this especially, we can make um, we can make this code common, so it's reusable, so we're not repeating ourselves here. So uh, we can have a function here called okay, and then now do we want to pair that with emitting the signal? Probably not. We'll keep that separate. We could, but put this here. That so we're not repeating that math. Absolutely, yeah. You're like 1 in the morning there. Which is kind of funny because that's where it was here when we spoke last. So we're kind of flip-flopping. But have a good night there, and thanks for saying hi for the second go, for sure. Cheers. All right. That is good there. And then let's see. So if not that, then we're using this common function. So we're going to call that here. But then we're going to move it in a slightly different way because the hammer position is going to be a function of the slide position, right? If the slide is here, the hammer is going to be halfway open. If the slide is here, the hammer is going to be 100% open, right? So we can make this a pretty easy, just linear type of deal. So if we go here, update, but we're going to move it first. And we have the location. So let's kind of look at this a little bit in well, yeah, no, we can do this. We actually still have a print statement even, so we can do this scientifically. We're going to have to turn on our debug window again, but that's easy. Okay, so let's say, let's see how that looks. Probably right there is where it should be fully down on the hammer. And it's going to tell us that is 65% open on the slide. So when the slide is 65% open, that's when it's going to click the hammer to the rear. And that sounds about right. Let's go with that. So on slide motion, percent open, direction, and not of the D&D model. Nice. Why, shoot it over if you ever want. I'm curious. Let's see. A video of the physical printed object or the 3D modeled like digital version? Oh, that's right. That's right. Um, what if you take, will it let you send the video ID? Nice. Yeah, I mean, toss them over. I think, like, for instance, what's a good example video I can use? What if you could send just like the video ID? I wonder if that works.
Your connection to the 2022 Mazda C.
Love advertisements. Like this sort of thing, you know? That's just a random example. Looks like it lets me do that. I'm not sure if it'll let you do that. Maybe it will. Oh, nice. Yeah, yeah, yeah. That's right. That's how we've done that before. I agree. Yeah, very cool. I'll keep a lookout. So, let's see. We have a number. So we want a slider. Right now we've got a slider from 0 to 100. We want to rescale it from 0 to 65. We only care about if it's at 65, that's effectively 100 for us. So we've got this percent open. So let's see. 65, which means it's 35 away from 100. Ah, and then no, no, no. That's absolutely not what we want to do. There we go. Um, and then let's kind of scale that. Ah, I have it. I have it. I have it. Is this okay for me to show on the stream to all two of us? Huh? Huh? Oh, I don't even need to download it. It'll just play. No way. That looks way better than I was expecting. That's 3D printed? There's like no lines on that though. That's nuts. Did you model that as well? Like humans and muscles and things are not easy to model. He's got shoes? Does he have like clogs on? He's got the axe going. That looks way better than I thought it was going to. I mean, not that they look bad, but usually you've got like some lines and stuff. Slippers, yeah. I was gonna say slippers, and I was like, I shouldn't insult him if they're not actually slippers. I love it. That's amazing. I like the hair. Does he have a wrench? Is he holding like a spanner? That's super cool. Did you end up painting, or is he blue? I feel like that's a wrench. Yeah, like a monkey wrench, a pipe wrench. That is super sick. That is really cool. Goblin helmet is what he's holding, or Goblin helmet's what he's wearing? So here, I'm curious. What does the model look like? That one's gonna download. Nice. This is a new Linux computer, so I probably don't have all the right codecs, but what I can do is I can just open it in the browser. That usually works. I think that'll work. I'll let that kind of cook in the background. Clear in the other one. Gotcha. Holding. Makes sense. Makes sense. Makes sense. Well, I will let my computer grab the codecs it needs. My experience with Linux so far has been really good. I uh whatever used it a fair bit, like in high school or whatever, 15 years ago, and it was like good, but there was a lot of things that it didn't do quite. But this is whatever where it's at now is bang on the money. This almost full parity with like a Windows or a Mac or whatever. It's pretty cool. But not my video codecs apparently. That's all right. In progress. Gotcha. Makes sense. Sure. Like there's a resolution of detail that you can't quite print. He looks a little larger than I was thinking too, which I'm sure that helps with some of the detail. Yeah. Like if you made him big enough, I'm sure you'd see the spider web pattern or whatever. Is there some like scaffolding? Like is there some uh just cutaway pieces that would be needed like as it prints? Sort of support is the word I'm looking for. Support. Let's see. Where did my codecs go? Oh, there it goes. There it goes. It did work in my browser. It did work in my browser. Oh, sure, sure, sure. Yep, I got it. Definitely Goblin helmet. That makes sense. Very cool. Very cool. So do you much like sculpting in terms of modeling? Like, because that's a cool model. Like I could not make that model. Not without a lot of practice. Thanks for showing me. Cool stuff. Let's see. So emit signal hammer struck. Do both. Nice. Very cool. Do you do that in Blender or do you use a different program in conjunction? Uh, Sculpting and normal modeling. Nice. Yeah, totally. Yeah, I've never done. Well, I've tried to make people and things. They end up looking very blobby. Blender and ZBrush. Nice. That's definitely something I'd like to get better at someday, is making organic shapes for sure. That's nuts. It's very uh very cool. Do you do and is that related to what you do professionally, or is that's just you doing it as a hobby, getting to that level of proficiency? Uh Move in open direction and it's not fully locked back. Any shapes in subdivision modeling is not to increase the subdivision division too fast. Okay, I could see that. Nice. Wow. Yeah, just doing it for fun. Very cool. Very cool. Very cool. Let's see. So And is not increasing the subdivision too quickly. Uh, what's the benefit of that? Do you get too bogged down in the details versus like doing the larger shapes kind of thing? Like you get too specific? Nice. I think you've told me before, doing embedded software devices makes sense. Let's see. So if it's moving in the open direction, it's not latched back yet. We want to change this number that's a 0 to 100. Start with too many polygons, it tends to get blobby. Gotcha. That makes sense. I could see that. Versus having like smoother shapes. You'd have like, whatever, too much detail too quickly kind of thing. Totally. Makes sense. Yeah. So if you're doing like a bicep or something, it's just like you can do 3 points, one at his elbow, one at his muscle, one at his shoulder, and then it just kind of makes a nice clean arc kind of thing or whatever. I'd believe that. All right. So we're going to cap it at 65, and then we're going to need to multiply it by something to make it a new scale. So you scale it from 65 to the maximum, then 100 as the maximum. So we're going to need to do a little math here, right? So it's just going to be what number. If the polygon distribution is uniform, you actually don't need that many polygons for many details. Huh. I believe you. I would have to try it to see what you're talking about. Because in my head, I go, if you're gonna do this, the veins in his arm or whatever, or you can see his uh ligaments or whatever. But I guess if you have a uniform amount across the whole surface, then there's enough detail. Interesting. I'll try to keep that in mind as I'm playing with it, because that sounds like good advice. So I'll keep that in mind. Get far with less polygons than you think. I'd believe it. Uh, so we want to find some number to multiply by 65. We type this in Google. We're going to get wacky suggestions. So let's just go into Notepad. Texts. There we go. So x times 65 equals 100. To figure out what that number is, x equals 100 over 65. So 100 divided by 65 is 1.538, and that'll probably work. Plenty good. Comment scale to 100. And let's maybe round it up a little bit so it actually does get over 100%. And now we want to rotate it to the position of the minimum rotation. If we look at the clamp here, it's just right here, degrees to radians, minimum right there. Or actually, it's right here. Okay. Plus that percentage that we've determined it is of the travel times the maximum rotation. And that should be it. And then we clamp it and away we go. I think that might just work. That might just work out of the box because then in the process function, it's going to check if it's fully clamped back. Let's just try that. Oh, no, no, no. Fingers crossed. Ah, too late. Didn't get it. Okay, it is making it twitch though, so that's something. Oh, I've got my debug window open still. I don't need that, do I? Sorry. Although we might need it in a moment here, I guess. So, let's see. What what is going amiss? Oh, well, and it might be to do with the spring. It might be to do with the spring, so let's look. See, because this code in here is pushing the hammer closed again. So how do we want to handle this? Well, what we could do, really the right way to do this would be to update the minimum. We maybe don't even have to rotate it then. We just update the minimum. So maybe, because so here we've got the minimum rotation. What if we have another variable called effective minimum? And then when we look at the process method, there's a lot of moving parts here. So I want to be careful that I understand what I'm changing before I change it. This is code I wrote a little while ago. Um, right. This line right here is where the spring tries to snap that hammer back to closed. So as an idea, what if we change this to the effective minimum rotation? And then when the slide moves, whether it moves in or out, all we do is we change the effective minimum. So instead of doing this, let's change it to this. Effective minimum is equal to, we're going to keep everything in degrees then, in this point, because then it, well, it calls degrees to radian in the other spot. And then we don't need to clamp the rotation or anything for this. So this isn't going to move it at all. It's just going to define, there's now something in the way that's changing the stop on that end of the hammer's travel. Missing parenthesis. Let's give that a go. Let's give that a go. Now we need to make sure that it updates when the slide is fully closed as well. And right now it doesn't do that. And that's easy enough to fix, but we'll cross that bridge when we get there. Let's make sure this works the way we're expecting first. No. No, it doesn't. Okay. Oh, okay, something changed. Oh boy. Okay. That's not working how I wanted it to at all, is it? All right. Okay. Right. So in the beginning, it wasn't even going into this block here. This is going to be a little bit of a puzzle. This is going to be a little bit of a puzzle. Okay. So if this is not being dragged, oh, that's a good point. Radians versus degrees. It might be. It might be. Because we're keeping this all in degrees at this point, effective minimum rotation. And then we convert that here. Speed. And the fact that the clamp is wrong is why it's going haywire. What's the minimum rotation supposed to be? 0. And the maximum rotation is 62 degrees. Oh, now this is a number between 0 and 100. We need to divide it by 100. That's first of all. Okay. That's part of the issue. That's part of the issue. All right. Okay. Something. Okay. Yeah, it's changing something, but it's not changing what I want it to change. There it only fell to a different position. But it's not causing it to move at all. Okay, okay. So I don't, so when it processes, if the hammer is not being dragged and the trigger is not being dragged, oh, and it's not at the minimum. So this we need to say effective minimum. That might be all it is. Now, again, hold on. This is only interested in moving it in the... Yeah, I've thought about that. I agree. Totally. Because if you're going to go to all this work to make the insides actually kind of be right, yeah, that'd be pretty cool. Have like a glass gun, for sure. For sure. Because there's these really cool animations, that are out there on YouTube or whatever. I'm sure that's what you're thinking of or you're aware, but um this sort of thing.
After saving with customized car insurance from Liberty Mutual, I custom.
Advertisements? There we go. So like these are pretty neat. Now, there's a lot of stuff here that I don't have in mine. Like, say all these little springs and transfer bars and things. Just for seeing the hammer better. Yeah, that's a good point. That's a good point. Just while we're debugging it, definitely not a bad idea. Uh, I'm not. Let's see. So here's the gun material. How do I go to the gun? Here we go. I don't know my way around the Godot texture editor super well. Let's see. But there's only one way to learn, right? Alpha scissor. Albedo. Here's the color. Does this have an alpha? Oh, it does. Oh, well. Oh, well. If it's that easy. I mean, will that work? Maybe not. Maybe it's not quite that easy. Let's see. All right, so let me. Oh, oops. Well, that's so it is. That is having an effect. Now we've got a freaking Chrome Makarov. Yeah, you would think. You would think. Uh, because that is the alpha. Maybe uh maybe there's another parameter we have to change. I might leave it be for now, but that is an interesting thought, even just down the line for debugging to be able to. What our alpha scissor does. Ah. Huh. Oh, there we go. Transparent. That might be it. That might be all we need. You know? And then what if we change the alpha to a little bit? See, maybe that's all it was. There we go. Ooh. Oh. I mean, that's kind of cool. Hang on, hang on, hang on. Oh, I like that. I like that quite a lot. Oh man, that's neat. Oof. That's pretty cool. That should be an option. There should be a button that lets you do that. Yeah. Oh yeah. Oh yeah. We're doing that. We're doing that. I might need to make my model a little cleaner, but like you can see the firing pin is actually two pieces. There's a firing pin for show on the outside, and there's a firing pin for show on the inside, and they don't quite line up. But that's okay. That's an easy fix. Easy-ish. All right, let's see. So how come the hammer? What's going on with that? Let's see. Oh, because, of course, this here. Totally. Yeah, exactly. Exactly, exactly. Um, so I'm trying to use this code to move the hammer for me, and that's fine. I think this is smart. So we're just saying the minimum is going to change, and that's it. Well, and we could do a combination of both. We do a combination of both. So this still can actually move it. This is the right answer. Instead of trying to do too much with one line of code, let's just make it simple. Let's go like this. Now, instead of rotate, here's the other problem. We want to set the actual rotation value, which is rotation.x. So that's the other issue. So rotation.x equals this. That was probably why it was spinning wildly before as well, because I was telling it to apply a delta, right? Rotate by a certain amount instead of set an absolute, right? The rotation value is 60 degrees or whatever, right? So rotation.x equals this, and then clamp it. And then we want to emit the signal. Oops, I just zoomed way out. Not what I wanted. There we go. And we also want to... No, we don't. It's not the hammer struck. Not the hammer struck signal. It is the... There we go. Progress. Motion. Signal. Now, will that latch it to the rear? I'm not sure, because where does it determine here? Back here. Is there any other place where we determine if that's true? Phew. Excuse me. Yeah, right now it only runs this if it's... So we could have this be another function. We don't have to duplicate this code. What do you want to call this function? Um, yeah, that works. Okay. And let's go right here. We'll call it check. Set is. Or something like that. I don't know. This function name's gonna get really long and it's gonna not be useful, but I want to be able to read it and know what it means. So there we go. All right, all right. Oops, wrong button. I think this might be it. All right, so let's make sure it still will click back. It does. Oh, kind of. Yeah, kind of. That sort of worked. Okay, so it doesn't move at all until we get back past a certain point. Okay. So that means my math down here is incorrect right here. Okay. Totally. Yeah, it's also absolutely. It's fighting the return spring as well. Um, so this part is working, kind of, but this part is not working. So, and to test that, we can actually deactivate the uh, the return spring for a second, just for a second. So we try. Oops, we wanna pass statement in here. So if we pull it back, oh, it still springs forward. Oh, because of the trigger. Oh, right. Ah. Yeah, that's the issue, because the trigger's got its own spring. And so it's fighting the trigger spring. Yeah, okay, I forgot. This is extra complicated. Eureka! That's our problem. Okay. Okay, let's look at the trigger. Well, so on here, this needs to be effective minimum rotation. And let's, again, comment this bit out for a second, just to make sure we're looking at the code in the right spot. Just kind of narrow it down. So now it should not spring back. Indeed, it does not. Okay. So that is what was happening. Okay. There we go. Now that looks like we would expect. Kind of. Kind of. Now it didn't latch it to the rear. It didn't latch it to the rear. So we pull it back. That's working. Right? That's working. Now, that's not going to be an issue because it's always going to spring itself forward in that case. So like this. So that's fine. Oh, well, here's the thing too. So, right. We do need this to be in a... This should be in an if statement here. If not cocked. There we go. I think that ought to be better. There we go. That's what it's supposed to look like. Oh, two rotations? Oh, yep, that's okay. Um, this one's clamping it. Although, we could just make this one command, couldn't we? We could consolidate this. and then we'd get the same effect. Yeah, same thing, but it's cleaner. I'm on board with that. So, and that's fine. We're gonna add the springs back in a minute after we decide how we want to handle that, but that works. That works. And then we pull the trigger and it releases it. But once it's latched back there, we can't pull it forward, pull the trigger. It's now free. It's just doesn't have a spring attached to it. Yeah, that works. So our math is fine. Our math for tipping it back, and that looks pretty good. We can see it even better because it's see-through. But that motion looks okay. So now we just need to make it work with all the springs. So now we've changed this to respect the minimum effective rotation. So that should be okay, perhaps. We go incrementally. We just add this piece back in. So yeah, that's fine. Okay. Okay. So now you can see if the trigger returns, the hammer returns. So that's the first part of that. Now I'm already kind of anticipating we're going to want to add an extra one of these in the slide over here. Now it's going to be a little wonky, but I think it actually makes sense because we need an event, a signal emitted, both when it starts moving, and since this all happens on a single frame, because the slide just moves so fast, we send two signals, and I think that's good. I think that makes sense. Oh, sorry. So now actually, oops. That's our non-existent high scores page, although it does actually work. Kind of. It half works. That's a project for next or near future. So here, now we need to get this stuff back into the mix. Active minimum rotation. Okay. That might just work. I doubt it. I really doubt it, but it might just work. Because we're no longer fighting the trigger anymore. Oh? Okay, it didn't give us a we didn't hit the firing pin. Interesting. How come not? I wonder. Yeah, we're not getting the hammer strike. But otherwise it's working. Okay. Okay. That's pretty good. So where does it here we go. Decide if the hammer's been hit right here. So the minimum should be 0, right? Minimum rotation should be 0. True. Yeah. Uh we could add um yeah, failures, stovepipes, uh all sorts of fun stuff. Light primer strikes, squibs, blow up the gun. uh, I'm not sure what direction I'll take that in. Uh, because we sure could, and that would make a lot of sense in a game like this because that's kind of the point, is that you're going into more than minutia of how the gun works. So I think that definitely will be a component at some point. Let's see. Okay, so I'm just curious if this is not going all the way to 0, because that would explain it. Let's get our debug menu back open. There we go. So we go like this. Oops. That's so cool that it's see-through and you can see it do this. The safety does absolutely nothing, by the way, right now, too. It's a fake safety. Although, I think on a Makarov it's also a decocker. So we're gonna have to figure that out. Because when you do this, let's say that the hammer's back and then you go up, it actually should safely lower the hammer. We'll get there. We'll get there. Alright. Safety off for now. So if we... See, that time it let us pull the trigger. And you can hear the sound of the hammer hitting, which is correct. But now if we do that, it no longer registers the hammer drop. And there you can see the effective minimum rotation is negative 0.000001. And that's why it's not registering. So if it's less than 1, then 1. 1 degree, right? Or we could say 0.5. And it's 0, rather, not 1. We could probably say, we could even probably say like 2 degrees or something. Let's leave it at 1. Let's leave it at 1 for now, and we'll give this a go. Okay. Because you should be able to just like, right. Okay, the trigger's kind of tripping out. We'll have to figure that out. It works fine there. It mostly works fine there. The trigger kind of flickers back and forth for a second. I'm not too worried about it because you don't notice unless you go real slow, and it works even otherwise. No, it doesn't. We're not giving any trigger progress. That's why. There's another method that the hammer needs to send a signal to the trigger. That's true. Okay, but it can still shoot now. You hear the clicky noise. Okay. That's good. That's good. That's good. All right. Oh, come here, you. Got it turned the wrong way. All right. So, boom. Yeah, that's cool. Yeah, I still think it should launch it more. It should still kick him out more if you move the slide back faster. So this multiplier should be bigger. Ah, this isn't spaghetti code. What are you talking about? This multiplier, right here. Instead of 1.6, let's make it like 3. Yeah, that puppy should go flying. Okay, so do we want to make this shoot? How we doing? So what's that gonna look like? It should be pretty easy, actually. Let's do it. Let's do it. Okay, so let's open the revolver for comparison. So here it is. So it's got this method called fire. And here we go. We've got an on hammer struck method. So that should be over here too. Here we go. Yep, and right now we're not doing anything. Yeah. And we also have this pull trigger method. On the, here we go. Here we go. Here we go. Pull trigger, we can fill in this function method. I could name it. I could name it, yeah. The trouble is there's so many different ones. Uh, I guess there's not really. Yeah, and I mean that kind of proves the point if I'm digging through it quite that much. Yeah, I'll if I do that, I think I might do it as more of a pass because like there's a lot of them. It's tricky. There's kind of an argument to be had either way. Kind of like if you make your code in small pieces in small files, then you can get away with fewer comments because it kind of speaks for itself and it can be actually cleaner. I don't know. That's very true. We could put it in the inspector and have it be as more of like a game design parameter. Absolutely. Totally. That's a good point. Ah, let's see. Yeah, even just for the sake of like going back and forth and going back and forth, back and forth, and changing and changing and changing it. Next time I do one of those, I'll definitely export it. That's a good idea. Uh, so here, oh, and I'm printing a lot. Where's my effective rotation print statement? It's in the hammer. Yeah, so we want to get rid of this print statement. Otherwise, we're gonna overflow the output every time here. We don't need the debug window open just now, or the console output or whatnot. So before now, oh, yep, there we go. It's not working. Um, so the hammer in this case is, I do have a name for this. We can do this. Okay. Now I don't know if I have a drop method on the hammer. Oh, I think I do. I think I do. Okay, that's good. Okay. Give that a spin. There we go. This didn't work. Where I'm actually just pushing the mouse. And that's pulling the trigger. So that's pretty neat. That's the first part of it. And then if we go here we go. On hammer struck. Now, we don't have this bound, and it would need to be bound, right? Because well, maybe. Okay, so let's go like this. I don't know if we're even calling this method right now. It looks like we are, actually. That's fine. Now, we don't have a crane in this case, but we do have is if... Now we're going to have to talk about if it's in battery or not. Okay, that's easy. We can do this. So if slide, and the slide is going to have a cartridge. So well, actually, the gun has a reference to that cartridge. Cartridge held by extractor. Yep. So if not, or if not, cartridge held by extractor, or, and then the slide has a position. So we're going to check if the slide is in battery before we fire the gun. So this slide has a percent open. Greater than 1. Out of battery. And or no round in the chamber. Okay, now we don't even have to worry about this because we have the cartridge held by the extractor. But we can check that it's not a spent cartridge. So it's a live cartridge. And we do that. Now, why is it mad at me about this? Identifier percent open. Oh, it's slide.percent open. Here we go. Cartridge held by extractor, strike primer, and fire. Now we don't have a fire method, so let's fix that. And we're just gonna plagiarize it from the revolver. And eventually, if we add a couple guns, we're gonna have to make a super class for this. There's gonna be a gun class, right? And they're all gonna have the same fire method or whatever. We'll get there, one thing at a time. That's a little bit premature optimization. Now we need to grab a bullet. So we have an on-ready var for bullet. Yeah, there it is. Preload. Go. Do I have other preloads in here? Nope, this is going to be the first one. So here we go. And then let's see. Okay, so here we got the fire method. Is that the only syntax error? Might be. Now this is where this random sound player would be again helpful. Now for now, I'm gonna be lazy. I'm gonna reuse the sound effects from the revolver, but we will eventually make specific gunshots for each pistol. But for now, we will just do it like this, just to get it working. And this might work. This might work. Okay. So Doesn't shoot, but now let's put a few rounds in the magazine. Did that strip around? Oh yeah, we got one in the chamber. So now... Oh, we crashed it. Okay, that's fine. uh, we need a muzzle position object to show where the bullet's going to come out. So, position 3D. Whoop. That's the muzzle. That's good enough for government work. All right. All right. Get in there, you. Not yet. Ah, there we go. Okay. So, still, nothing because we don't have a round chambered. Now we do. Hey! Now, it's not going to shoot again because what should happen is when we fire it, it works the slide. And we can do that. But right now we can do it pretty manually. Huzzah! Uh, right now it's a single shot pistol. And I goofed. I shot the same target twice. Otherwise we'd get the moving target. There we go. Here we go. Moving target. This is so hard to hit. Ah! Hey! And now we open the gate. There it is. Sweet. Okay. So I think this is actually because we've done our homework, like we've fully fleshed out everything else. This is going to be fairly simple because we already have ejection, right? And we already have uh, all the springs coded. So all we have to do now is when you shoot the gun, it slams the slide back to the rear. So let's code that super quick. So if we go into the slides code, let's add a new function in here. We're in the right keyboard layout. Still can't type, even in the right layout. So what we want to do here is we just want to literally set the position to the full extreme rearward, which is max open. We're going to emit a open signal, so it is opening. And we can recalculate the percent open. And I think that's legitimately like all we need to do. And then in the fire method, we'll tell the slide that it's being pushed back by the pressure of the gunshot. Why doesn't it like that? Slide. Identifier slide is not declared. Oh, because we're in the wrong gun. This is the, I better close this before I edit it incorrectly. Here we go. That was the revolver code. Okay. Now, hopefully, this is just gonna work. And it's gonna feed the next round. That's the next step. That's the next step, is we need it to actually feed. There we go. Oh. Uh-oh. Okay, something happened. I think I think it's firing in full auto is what's happening. Oops. Hang on. Hang on. Yeah, let me show that again. Accidental machine pistol. Yeah, hang on. Let's go over here so we can watch what's happening. I'm just gonna hold down the trigger. All right. All right. All right. Well, and look, it even locks open when it's done. Wow, that's pretty cool. That's pretty cool. We accidentally we accidentally made a machine pistol. Pretty great. We're gonna burn through all our ammo is what we're gonna do. Let's do that one more time, just for the heck of it. That's pretty great. That's pretty great. You'll love to see it. Oh, we need to get that old magazine out of there. All right. All right. Okay. How do we fix this? Okay. The trigger should reset. The trigger should uh the sear should hold the hammer back after it's fired once until the trigger resets. Good. Let's fix one other thing first before we do that. The uh the slide speed is too low right now. Yeah, so we actually should set speed. Say 90 and see how that looks. Oh, here we go. Here we go. This is an instance where we should export this. So, let's see. And then how do we see that over here? We got to look at the right objects. This is the slide. Well, okay, and then so we're gonna actually make this a constant. So let's call it um we should probably comment it up here, actually. Uh right. Right, right, right. Okay. So then go here. And we look at the inspector for this slide. It's here. Here we go. We have this recoil impulse speed. So now if I move this window over here for a second, and then we run the game. Oh, but it ran the game in the wrong window, didn't it? Okay, let's see. Can I do this? And then, yeah, it's still gonna go over there. This. No. There we go. Okay. Uh, now it's gonna test my Linux knowledge. Can I go? Here we go. Yep. Back to this window? I can. There we go. There we go. Okay, so we could adjust this value. Oops. Touche. There we go. Okay. Cool. So now let's. This wasn't an issue when it was when we were firing single shots, but we might we might want to like automatic load button or something. Okay. There we go. All right. So the idea here is that it will kick them out correctly. Because right now it's doing them at the minimum speed to dribble them out. They should go flying out of there a little faster. Okay. We didn't get to really see it because it hadn't loaded the sound effect yet. Here's the thing. We can actually get 9 rounds going because we can load the chamber and then we can top up the magazine for maximum full auto. We'll fix the full auto. It's gonna have a sear that resets. That's how it should work. But while we have it, let's enjoy it for a second. Okay. Yeah, that works. Now they really go flying. But like more straight up than I would have thought. Oops. Yeah, there we go. All right, we're out of bullets. So this is our it's our last magazine. But pay attention to the direction they eject. They go straight up. Quite quickly. Quite quickly. So maybe that speed is too high. This will give us more bullets, but it'll give us more revolver bullets. So that's not going to help us. It won't let us put those in here. Yeah, it's going to break. Yeah, which is good. It should. It shouldn't let us do that. Okay. Cool. All right. Oh, but I'm silly. We had this exported, so we could have changed that number. Oh, well. Here we go. We'll do it this time. So, load this up. It's going to be a mag loading stream. What we're doing right now is changing the ejection speed, right? So 90, I've realized, is a little bit too high. So there we go. Yep, that works. Easy. Let's change the number from 90 to let's try a much smaller number, like 10. Let's see what that looks like. It's still pretty extreme. Let's try a smaller number. The other thing is they go straight up, actually. And I was intending for them to go kind of sideways, you know? It's a little weird. That's a cool shot. That's a screenshot right there. That's a thumbnail. There we go. Uh so let's before we burn all these rounds, let's fix that number. Go down from 10 to like, what if we do 1? What if it's meant to be less than 1? What if it's a scale from 0 to 1? Try that. See, that looks better. See that? Oh, that looks great. Oh, that looks amazing. That looks fan-fricking-tastic. Okay, one more. One more. Let's do it again. This has to be like an unlock. If you like get a high score or something, you've got to be able to unlock the full auto Makarov. Oh. Okay, wait, we can top it up too. We've got one last bullet. There we go. Okay. Look out, Mr. Acorn. I'm coming for you. Alright, alright, alright. I'll be done, I'll be done. Oh. I love it. That is amazing. That is so good. Alright. Alright. I might end on that note. I might take a break here. Um, but the next task is obviously to make it semi-automatic. Alright. Thanks everyone for stopping by. I hope you all have a good day there. And yeah, absolutely. Thanks for checking it out. Cheers.